Hello students, as we have already started with our operating system lab in the last video, we have completed the first program execution, that is simple calculator by using some arithmetic expressions. Now let us learn with the second program, that is develop a program to compute the roots of quadratic equation by accepting the coefficients and printing the appropriate message. So before we start with this particular program, let me explain you what exactly the quadratic equation means. So let me open the lab manual first. This is our lab manual. Here, develop a program to compute the roots of quadratic equation by accepting the coefficients and printing of appropriate message. So first, we need to write the procedure as I have told in the last video. Then we need to write the input, expected output. After that, we are going to write the algorithm for our quadratic equation. So, quadratic equation, first let me explain you what is quadratic equation exactly. So, quadratic equation is nothing but it is like ax square ax square plus bx plus c equals to 0 or ax cube. This is what the quadratic equation we will be having. So we need to find out the roots of the quadratic equation by writing the formula. So I'm clearing this. So this is what our algorithm is. And let me come to the program and give the explanation. After drawing the algorithm, we need to draw the flowchart based on our algorithm, whatever we have written. After that, when we come to the program, as everybody knows that we need to first include the preprocessor directives that are nothing but the header files. Here we are going to use few of the math functions like sqrt in the program, so that even we have included the math.h header file in the starting of our program. So first header file, as everybody knows, that is standard input output header file, and the second header file we are using, that is math.h, because we are going to use math functions in our program. So after writing the main function, first we need to declare the variables whatever we required for our program. So we have declared the variables A, B and C. We are going to declare for our equation, and D we are going to declare, and R part is nothing but the real part, I part is nothing but the imaginary part. We may get the roots as real and imaginary, because of which we are taking R part and I part in the starting. And root 1 and root 2 we are taking to store the square root results, because of which we are taking the root 1 and root 2 variables in the starting line. After that, I'm writing a printf statement for asking the user to enter three coefficient values. After that, I'm reading those three values by using the scanf function. Here in the scanf function, we have written percentile f. Why we have written the percentile f? Because in the starting A, B, C values, we have declared it in an floating kind data type, because of which we have written here percentile f for reading the values of A, B and C. After that, we are going to first check the condition. If our A value and B value is 0, then we are going to print the result as invalid inputs, because we need to give some of the values, then only we can find the roots of the quadratic equation. After that, we are writing else if, only if A equals to 0, then we are getting the printf linear equation, and this is the formula to find if our A value is 0. Just root 1 equals to minus C by B, and we are trying to print that particular result. If or else, we have one formula to find the result. First, we are checking for if A equals to 0 and B equals to 0, then we are printing the invalid input. After that, we are checking only if A equals to 0. If not this both cases, we are going for the third case. That is, here we are going to use if else ladder to solve this particular program. Here the next else we are writing the formula d equals to b into b minus 4 into a into c. To find out the roots, we have the formula b square minus 4ac. That I am trying to store in a d variable because we need to find that b square minus 4ac again and again. So if we find out here that d, we can use it anywhere. After finding out b square minus 4ac, if that particular value, if we are getting it as 0, then we can print the roots are real and equal. And we are finding the root 1 value minus b by 2 into a, and root 2 equals to root 1. Both roots are real and equal. And we are trying to print that result. And if the d value, whatever we are finding here, if that value is greater than 0, then whatever the roots we are getting, the roots will be real and distinct. And this is the formula for finding out the roots. Minus b plus square root of d by 2 into a minus b minus square root of d by 2 into a. Then we are trying to print both the roots, that is root 1 and root 2. Here percentile 3f is nothing but it will give some space when it is printing the result. And if d is equals to 0 is one case, if d is greater than 0 is another case, and one more case is if this both are not the case, then what? Here also we again used if else ladder here again. So here in if both the cases are wrong, like if d is not equals to 0 and if d is not greater than 0. If this both are false, then the last else part will be executed. So printf, enter the roots are imaginary, and this real part we have the formula, imaginary part we have the formula. That we are going to find out the real part and the imaginary part. Then we are going to print that real part and imaginary part as result. So let me go to the VMware workstation and show you the execution of this particular program. The same program I have already kept here in the VMware, as we have seen already. So I'm closing this. Let me open the program again. So as in the last program I have shown, I have created one folder. Inside the folder, I have already typed that program by the name week2.c. Here I have typed the same program, included the header files, then the same program I have written. Now I am trying to run this program. To run this program, we need to go to Application, System Tools, Terminals. After that, we need to first go to that particular directory. After going to that particular directory, to run the command, we have the command cc space week2.c, enter. So it is showing undefined reference to SQRT. Whenever we are getting such kind of things, like SQRT function will not support in this Red Hat Linet. To compile this program, we need to give cc space week2.c space minus lm. This is the command to compile your program wherever you are using any of the functions which comes under math function. Enter. Then we don't have any errors. I'm trying to run the program. As everybody knows what is the command for running, ./a.out. So here it is asking to enter the three coefficients. So already the first condition was if our a value is equals to 0. If a value is equals to 0 and b value is also equals to 0 and c value I am giving some 1, then it will show you invalid input. This is our first case. Then when I go with the second case, it was that if our a value is 0, b value is 1 and the c value is 1 again, it will show you linear equation. And I am going for the next. I am giving the a value as 1, b value as 0, c value as 1. It is showing the roots are real and equal. Then next I'm trying it again. I'm giving the values as 1 2 1 3 1 2 1 2 1 3. It is showing roots are real and distant, and it is calculating that particular roots. Let us try for real and distant one more thing. So I'm giving some 20, I'm giving some 32, I'm giving some 21. So again, you are getting the roots are real and distant. These are all the different cases what we are going to find the roots of the given equation. Hope everybody understood the week 2 program. Thank you.